Hi, you must be familiar with these cylindrical cells. This is an 18650 nickel manganese cobalt cell. So you must have noticed that in these cylindrical cells, the negative side is circular plain disc like this. But on the positive side, there are gaps that are available all around the circular disc, and the disc looks like it is separated from the body in some way. So why this kind of structure exists on the positive side? Hi, this is Vivek. Welcome back to the channel. Let's find out more about this structure. Let's get back to the presentation screen. Now, in order to understand the positive side or the cathode side structure of the cell, we have to look a bit into the contents of a cell, what is there within a cylindrical casing. So there is this gasket. Gasket is used to provide insulation between the positive and the negative electrode. So basically, you know that this is the cylindrical casing, and this entire casing is negative in nature, not only this terminal. And the positive one lies over here, it comes internally from the internal structure. So basically the insulation between this positive and the negative electrode is provided by the gasket. Then there are terminals, of course, positive and negative. PTC is a safety device. It stands for positive temperature coefficient, which means these are the devices whose resistance increases with the increase in temperature. The temperature again increases when the current withdrawn from the cell is out of limits. Therefore, the cell begins to heat up, and therefore this PTC increases its resistance so that this current can be put to control and a kind of safety is achieved. Then there is CID. CID stands for current interrupt device. Again, this is also a safety feature. It works with this vent. Vent is there to provide an exit to the gases that are formed within the cell, so that the entire casing doesn't burst up. Instead, there is the vent provided. We saw the circular disc on the positive side, and there are these gaps that have been provided. So these gaps are nothing but these vents. They provide safe exits for these gases that are generated within the cell. So these are the things that exist within a cell. Now let's look at the internal structure of the cell. The internal structure of the cell is nothing but a jelly roll of positive, negative, and separator. So these are the positive, there is the positive electrode, negative electrode, and both of them are separated by a semi-permeable separator. So all of that is rolled on this central rod that you can see, and there all the positive, then a separator, then a negative. This kind of jelly roll structure is there within the cylindrical casing. Okay, here you can see there is the metal top cover which we see on the positive side. Then there's a safety valve. Safety valve is the vent which provides safe exit for the gases within the cell. Then there's the insulation ring. Insulation is made of the gasket and the positive electrode collector. Then the case is there. Then negative electrode character. Negative electrode is in the entire body is negative in nature. Okay, and positive electrode collector, it basically is a tap that comes out of the positive electrode and is connected here using spot welding. Okay, now let us understand a bit more in detail. So here you can see this is the jelly roll kind of a structure where the positive, negative, and separator, all of them are rolled on this central rod. Then from the positive side, a tap is taken out like this. You see, this is the tap that is taken out. The negative is in the entire body is connected to the negative side, but from the positive side a tap is taken out and is connected to the current interrupt device. In this picture it will be more clear. So here you can see this is the positive tap, right? It is going like this and it has been spot welded here. Okay, so this what you are seeing is the current interrupt device. You see the current interrupt device. So here it is a spot welded. Now what happens, why this kind of a structure exists? Here you can see these gaps are there, these are vents. Now what happens is that through these vents the external air pressure is exerted on the internal current interrupt device. Okay, so the current interrupt device is under an equilibrium between the internal gas pressure that is created within the cell during thermal runaway condition and the external air pressure. Okay. Now, when the internal pressure, let's say because of thermal runaway, let's say a huge amount of current is going in the cell or out of the cell while charging or discharging, then the first thing that comes into action is the positive temperature coefficient, PTC. This tries to control the current by increasing its resistance, and therefore it tries to stop the current from going out of limits. Now let's say if this PTC is not able to handle this situation, then what will happen? Due to huge amount of current being withdrawn, the electrolyte within the cell will start dissociating and will start making compounds and gases like carbon monoxide and various other acids that will be created. So now all these gases that are formed within the cell, they start ascending upside. They exert a force on this CID, and therefore the CID under pressure, because the internal pressure is greater than the external air pressure, it breaks. As it breaks, the positive side connection is lost, and therefore this side has no positive connection. So therefore the current is stopped here, and therefore there is no flow of current out of the cell or inside the cell. So this is a kind of safety mechanism that has been provided, that this CID is just loosely connected well enough that under normal condition it works normally, but if there is an abnormal situation where the current is going out of limits, this CID breaks open, and all the gases that are generated, let's say the pressure is very high, all the gases go out on through this vent. Okay, let me change the color. So all the gases go out of these vents, and therefore the cell is protected. Now why this venting is important? Because if there is no vent provided and this is completely sealed off, this cell body will not be able to handle that high amount of pressure that is generated within the cell, and therefore it will burst open on any side, which will be more dangerous, because not only the harmful gases will exit with high pressure, they will come up with molten metal parts, because under thermal runaway the cell temperature may easily go to thousands of degrees Celsius, which is enough to melt the metal parts that are there, like copper or aluminium. All these metals are there on the positive and negative electrode, so all these metals will come out like projectiles and the gases, and it may also catch fire and explosion. Now there is a problem that is there with this kind of design. I told you that here the CID breaks open under the thermal runaway condition. Now if this CID breaks open and there is a load connected, let's say any kind of load, mostly if you use electric vehicle, there is inductive load or maybe other kind of load which is withdrawing huge amount of current, this sudden break opening of this CID also creates sparking. As this spark is created, here a spark is created, and there are the gases that are venting out. These gases are carbon monoxide and various other explosive gases, which will instantly catch fire, and that's why we see thermal runaway conditions. That's why we see batteries catching fire, which is not only dangerous for the cell itself, it is also dangerous for the nearby cells in the same battery pack. So that's why this is a safety mechanism, but it has its own limitation. So I hope in this video I gave you a clarity on the cell design and why the positive side structure is different from the negative side. Thanks for watching. Let me know in the comment section what do you think about this video. Any suggestion, query, question, comments or feedback will be highly appreciated. Share this video with your friends if you found this video to be helpful. Subscribe to the channel if you haven't already, and hit the bell icon notification button so that you can keep on receiving such interesting content always. This is Vivek signing off. Thank you.